Hello, let's continue our Sudoku adventure with lightning sums by Strosahl. So we have normal 6x6 Sudoku rows. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6, exactly once each. We also have X-sum clues outside the grid, these numbers outside the grid. The way these work is whatever digit is right next to the clue. So in this case, it's in the row starting from here. In this case, the column starting from here, whatever that digit is, say it was a 4. That tells us how many digits are involved in the sum. So if this was a 3, there'd be 3 digits. If this was a 4, there'd be 4 digits starting from here and including itself. And those then all need to sum to the clue outside. So if this was a 4, all 4 of these would sum to 13. Maybe we could do a 5 that gets us to 9. We need 4 more, so 1, 3. So hopefully I did that right, but yeah. So that would reach us to 13. So including the 4, we count 4 plus 5 plus 1 plus 3. That is 13. That matches our clue. So that would be one way to fulfill this. All right. In addition to that, we do have these blue lines in the grid. These are region sum lines. So what these do is they segment every time they cross a box boundary. So we have the green segment, then we cross into a new box. We make the purple segment, then we cross into a new box, and we get the orange segment. Now, all of the segments on the same line have the same sum. So whatever these two green are, say this was, I don't know, 3, 4 adding to 7. Then the purple also have to add to 7. They don't have to be 3, 4, but they have to add to 7. Maybe 1, 6 to add to 7. And then here we could do 3, 4 again. We could do 1, 6 again, or we could do a 2, 5. All that matters is that the sum is the same. Segments on the same line have the same sum. On different lines, they could have different sums. So like that doesn't mean this also sums to 7. It could, but it doesn't have to. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, how do we want to get started here? It feels like the overlap between like this 13 and the fact that we have these blue lines is important. They're also defining sums. This 12 is doing the same thing. All right, so let's get some minimums and maximums here. We can't put a 1 next to any of these clues because the only X sum 1 that starts with 1 is a 1, right? Because it only includes itself. It is a 1, and so that would have to be a 1 clue. So it's not going to be a 1. Now, the maximum of a 2 is 2, 6, which is 8. So none of these are 2 either. The maximum of a 3 is 3, 5, 6, which is 14. So every single one of these could be a 3. Now, the minimum for 4 would be 4 with 1, 2, 3, which is 10. So all of these could be 3 or 4. Now, the minimum for 5 is 1, 2, 3, 4, 5, which is 15. So none of these can be 5. So actually, all of them are from 3, 4 only. We use 3 digits or 4 digits. Now, that's interesting. So that means either the 10 and the 13 share 3 or 4, like not share, but one is 3, the other's 4. And then the same for the 12 and the 14, just because the pair in the box. So, okay, so if we used the 3 here, then these would sum to 10. And I think that does that work? It's really limited because that would mean that the sum on this line is 10. And so the only way to do 10 is 4, 6. Oh, no, it doesn't work because the only way to do 10 is 4, 6. I was thinking 4, 6 here, 4, 6 here, 4, 6 here kind of works. But no, because 3 here would put a 4 here. And so now we can't actually add to 10. So this is our 4, this is our 3. That's pretty simple logic there. And so now these 3 end up adding to 9 without a 4. So not 2, 3, 4. So they have to use a 1. So there's 3 ways to add to 9 and 3, just in a void. There's 1, 2, 6. I'll just write them out here. 1, 2, 6. That's if we use 1 and 2. If we continue using the 1 and we move up to the 3, we can do 1, 3, 5. But now we have to stop using the 1 because you can't do 1, 4, 4, right? So now we can use the 2 and we can go 1 to 2, 3, 4. But then that would be the minimum if we don't use a 1. So these are the 3 ways to add to 9. Now you'll notice we don't have a 4, so we can't do the 2, 3, 4 case. So we're down to 1, 2, 6 or 1, 3, 5. So 1, 2, 6 could be in any order. And then 1, 3, 5, the 3 would be here. And so then this would be a 1, 5 pair. So those are kind of our options for what it's worth. 1, 2, 5, 6. Interesting. I mean, I guess that's anything that these could be. Like that's literally what the box says. So I'm not sure if that's useful. The other thing we can think about, if we maybe it's a little cleaner, is the outies, these two cells, because we know that these 4 add to 13. We also know the entire row adds to 21 because 1 to 6 is 21. So what? How do you get from 13 to 21? Well, you have to add 8, right? Did I do that right? Yeah, you have to add 8. So these two add to 8, which means we're missing the 2, 6 or the 3, 5. That's what we're missing from these, which I guess is kind of the same way of saying the same thing. But I wonder if we should think about the 12 and the 14 then. So if this was a 3, then these two would sum to exactly 9 without a 3 or a 4. And that doesn't work, actually. So if this was 3, these two would sum to 9. This would be a 4. So we don't get to use 3 or 4. How do we sum to 9? Well, we can't do 1, 8. Can't do 2, 7. Can't do 3, 6. Can't do 4, 5. So there's no way to add to 9. So this is our 4 and this is our 3. And that means this doesn't have 3 on it, the sum to 9. And so the only way to do that is 1, 2, 6. And then the 3 ends up over here with the 5 to add to 8. Okay, well, that was easier than I thought. It's a little difficult for this to just be a 1, 2 pair adding to 3, because this would also be 1, 2, and this would be 1, 2. All right. What's the outies for 12? The outies for 12 are 9. So these two add to 9, which is either 3, 6, or 4, 5, but they can't use the 4. So actually, this is just always 3, 6. So I guess there's only one way that this is adding to, I guess, adding to 8. We always have to use the 1 and adding to 8 in 3. And then we need 2 digits that add to 7. But we can't use the 4 or the 1. So it's got to be 2, 5. Yeah, that lines up. Okay, just double checking that math. I was sure it was right, but just another way to approach that. So again, okay, we know this isn't a 1, 2 pair. We also know this isn't a 1, 2 pair. So this is the other 1, 2, and this is the other 1, 2. So that this can either add to 7 or 8. So that means this can't be a 3, because if it's a 3, we're not adding to 7 or 8. We're adding to 4 or 5. So this has to be our 6. That's our 3. That makes this our 6. And these are the same digit as each other. Okay, so this is interesting, because if these are the same digit as each other, where does that... So if they were both 1s, where does the 1 go? If they were both 2s, where does the 2 go? It goes over here. This is where green goes. And because it's the same green digit, we know that we have to use 6 with it to add to whatever we add to. So 6 ends up one of these two. I guess that Sudoku told us the same thing, or whatever. Sudoku told us the same thing. That's 1, 2, 5. So suppose we can say that this is actually nice. This is the purple 1, 2. This is the green 1, 2. This is the purple one, because they share a row. They can't be the same as each other, so they're different. And now you'll notice that this cell sees a purple 1, 2 and a green 1, 2. So how could it be a 1, 2? It can't. So it's a 5. And this is the purple 1, 2. Meaning the 5, yeah, we know the 5 is one of these two. So that's 3 and that's 5. Okay. So we should probably think about these. In 3 cells, we need to add to 10. We already have 9, so that's our 1. 3 cells, we need to add to 14. We already have 8, so this needs to be 6. Is that right? Yeah. So that places the 6 here. Greens are 2 and purples are 1. Okay. So this is 2, 4, 6. It's not 4, that's not 6. This is 2, 4. Probably have to use some of these other lines. This is a 1, 5 pair, and we know the order. That's 5, that's 1. This is our 2. Okay. Let's just get much Sudoku done as we can. 2 or 6. This is also 2 or 6. Here we need 1, 4, 5. That's not 4, that's not 1. Here I need a 4 or 5. Okay. These two digits are the same as each other because, whatever this digit is, where does it go in this box? Well, it's not the 1 or the 6, so it doesn't go here, and it doesn't be in the row. So these are the same digit as each other, meaning these have to be the same digit as well to get the same sum. So they better be the 4. That gives us the 2, 6, and 4 here, the 2 and the 6 here. That's 5, 1, 4. That's 5, 1. All right, so this is the 2. This is 5, and then these are both 3s. All right. Got it done. Cool puzzle, Strosahl. I enjoyed that. I hope you did as well. And if you did, then why not leave a like, subscribe, and a kind comment below.